Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaro. Students, in this general science physics, we have already started with the topic electricity. In that topic, we have completed some of the important points: charge, Coulomb's laws, electric current, resistance, conductance, resistivity, and also conductivity. These topics we have completed now. So if you want previous, you can just click on the playlist. You can find out the previous session. And let us start this session. So now in this session, we are going to discuss the potential difference or potential. After that, maybe Ohm's law. Okay. Electric potential. Electric potential denoted with the letter V, also called as voltage. Okay, so electric potential V is equal to nothing but work done on unit positive charge. Work done on unit positive charge. Positive charge. So work done W, charge is nothing but Q. So V is equal to W by Q. For example, if the positive charge at this point, if it has to move from this point to this point, that is A to B, then there is some work has to be done. So that work done on this unit positive charge to move from A to B point is nothing but potential. Whenever it has some potential, then it moves from A to B. So that means you can also say that it is the energy required to move the electrons from one point to another point, or to move the charge from one point to another point. So that means whenever there is energy, the electrons are moving. So that means whenever there is energy, the electrons are moving, means you can say the current is flowing. So that means whenever there is a potential, whenever there is a voltage, then current is flowing. Okay. So whenever we apply some voltage, then current will be flowing. Or whenever there is some potential difference, then also current is flowing. Okay. So voltage or potential is equal to work done by unit positive charge. Units of voltage or potential is nothing but volts. Here 1 volt is equal to, work units are joule, charge units are coulomb. So joule per coulomb, very important. 1 volt is equal to 1 joule per coulomb. Okay. Here we can understand this voltage or potential. If we apply the voltage, then current will be flow. Current will be flowing. Okay. So that means, for example, if we can understand this one, if it is here we have the water, let us take a water. Here we have the pipe. That pipe is almost horizontal. Okay, almost horizontal. So in this horizontal pipe, if you give some water here, if it is let us take 1 kilometer or 100 meters, then water may not easily flow from one side to another side. Why? Because there is no height difference. Whenever there is no height difference of the pipe, then water flowing is difficult. If you make the difference like this, the pipe is, if you make like this, then if you send some water here, water can easily moving from higher side to lower side. Why? Because here there is a pressure difference is there, height difference is there. Okay. So that means whenever there is a pressure difference, then water is flowing. In the same way, if you can consider a conductor, if it is a conductor, here zero potential, here also zero potential, then there is no difference. There is no difference in the potential, so then there is no current is flowing. No current is flowing. For example, in the same conductor, here if we have 10 volts, here we have 0 volts. Now there is a potential difference. Like here pressure difference, here potential difference is there. So whenever there is a potential difference, then current is flowing. Current is flowing. Okay. So same like whenever there is a pressure difference, water is flowing. In the same way, whenever there is a potential difference, current is flowing. Okay. For example, if you want to send the water through this perfectly horizontal pipe, then what we have to do? If you put one motor here, if you put one motor here or one pump, then what will happen? Water can easily flow from one side to other side. That means this motor or this pump gives the energy to move the water, correct? That means it creates the pressure difference. So that's why water is flowing. In the same way, here also, for example, if you want to send the current through, zero potential here, zero potential here. If you connect one battery here, let us take a 9 volts battery. Now it is creating here 9 volts, negative means 0 volts. Now there is a potential difference. Now whenever there is a potential difference, then current is flowing. That means here it is the voltage or potential, it gives the energy to move the current. So that means whenever we apply the voltage, current is flowing, or whenever there is a potential difference, by default there is a potential difference like this, then current is flowing. Okay, so you can note down the points. Current will flow only the cases, the first point, if we apply the voltage by external or whenever there is a potential difference. Very important point. Whenever there is a potential difference. If we have the potential difference, then only current is flowing. Otherwise, no current is flowing. And the second condition is nothing but the switch or circuit must be closed. Okay, so whenever the switch is closed or circuit is closed, then only the current is flowing. Otherwise, the current is zero. Let us take that one. For example, here we have applied some 10 volts of the current. Here we have the switch. This is the switch symbol. Symbol also very important. Here we have the switch. Here we have the bulb. Okay, this is, let us take a case one. Here switch is open. Switch open means, all of you note to this point. Switch open means switch off. Okay, in our normal terminology, switch open means switch off. Whenever the switch off, there is no current is flowing. Current is zero. And the second case, same thing. If we have applied a 10 volts by using a battery, here there is a switch, here there is a bulb. Okay, now switch is closed. Closed means this point is connected to this. Okay, now you can say switch closed. Switch closed means switch is on. Whenever the switch is on, there is a current is flowing. Bulb glows. These are very important points, guys. current will flow only in the two conditions whenever we apply the voltage. That means we have to give energy by volt, or whenever there is a potential difference. Already there is a difference is there. And the second case, the switch or circuit must be closed. Whenever there is a closed circuit, then only the current is flowing. Note all these points, very very important. Each and every point is important. We know very well the exams are in so many shifts. Okay, so that's why lot of questions they will frame. Okay, so electric potential is nothing but work done by unit positive charge, that is joule per coulomb. 1 joule per coulomb is nothing but 1 volt. Whenever we apply the voltage or whenever there is a potential difference, current is flowing. Switch open means switch off. Switch closed means switch on. Okay, noted? Okay, in the same way, in the previous session we have discussed that current is measured by ammeter. So here voltage or potential measured by voltage is measured by voltmeter. Voltmeter. Okay, so voltmeter is denoted with V upon the circuit. In the previous I have given ammeter is always connected in series. Here voltmeter always connected in parallel. Voltmeter is always connected in parallel. Note down this point. Voltmeter always connected in parallel, or you can also say that is shunt to the circuit. Okay, that means if you want to measure the voltage across any bulb, we have to connect in shunt or parallel. That means here if you have applied a voltage, here let us take a switch is closed. Okay, here you have the bulb. If you want to measure the voltage across this, we have to connect the voltmeter like this. That is parallel. Always we have to connect the parallel. And ideal ammeter having zero internal resistance. Here internal resistance of ideal voltmeter. All these points are important, guys. Ideal voltmeter is infinity, very high resistance. Okay, ideal case infinity. Note on these points, infinity. Okay, and if you want to measure a small potential difference by using potentiometer, another device, by using potentiometer, we can also measure small difference in the potential or small potential difference. Okay, that means if we have inbuilt some potential difference is there, then we can by using the potentiometer we can measure the potential difference. This point also very important. Okay, and in the previous ammeter case, that is current case, we have discussed that whenever there is a open circuit, current is zero, and short circuit, current is flowing. Okay, here also same. Whenever there is a open circuit, voltage is high or almost very high potential. Okay, closed circuit means voltage is zero. Same like that. Okay, so note down. In case of open circuit, circuit is open. Okay, open means, for example, there is no contact between the source and load. This is the bulb. There is no contact. It is the open circuit. In this case, the voltage across open circuit is high, or if it is a voltage, source voltage is Vs, here the voltage across this is almost equal to supply voltage and the current flowing is 0. Okay, here in case of short circuit, in short circuit the voltage is 0, current is maximum or high, current is maximum or high. Sometimes they will also give the question on this. Okay, so after this we have completed current, resistance, voltage. Is there any relation between these three? Voltage, current, resistance? Yes. Yes, we have. That relation is given by the law is called as Ohm's law. Very important. Ohm's law. Very important. Ohm's law. Okay, it gives relationship between, direct question, relationship between voltage, current and resistance. Students, if I forgot any important point, you no need to worry. That point may be covered in MCQs. Okay, so we will also discuss the topic wise MCQs. In that will cover. So Ohm's law gives the relationship between voltage, current and resistance. He has stated like this: at constant temperature, at constant temperature, at a constant temperature, the current flowing is directly proportional to the potential difference. The current flowing is directly proportional to the potential difference. If you have more potential difference, more current is flowing. Less potential difference, less current is flowing. So directly proportional to the potential difference. Potential difference. Okay. Or we can also say that if we increase the voltage, if we increase the voltage, that means applied voltage, current also, current increases proportionality. Current increases with proportionality. Okay, that means if you increase the voltage, current is increases, or if you current is depends upon the potential difference. Whenever there is a potential difference increases, current also increases. So if you replace this one, V is equal to I into R. So that means if you replace the proportionality with equal to, we have to add one constant. Na? That constant is equal to R. So that means whenever there is a resistance is constant, then only this will be true. When the resistance is constant, whenever the temperature is constant, resistance also constant. So V is equal to I into R. It is a very important relationship between voltage, current and resistance. From this, if you want current I is equal to V by R. If you want resistance, R is equal to V by I. So they may give in any of the manner. R is equal to V by I, or I is equal to V by R, or V is equal to I into R. This formula also important in the numericals. Okay, note down this point. So for the constant voltage, if you current increases, resistance decreases, like that. So from this you can also they say that resistance inversely proportional current, or current is inversely proportional with resistance. Okay, noted. And some important points belongs to this Ohm's law. Ohm's law only applicable to conductors. Ohm's law only applicable to conductors, and as soon as temperature as constant. Temperature is constant. Okay, and it is not applicable to, these are very important, not applicable to semiconductors like silicon and germanium, semiconductors or semiconductor devices. For example, they have given diode, transistors, all those. Okay, semiconductors, vacuum tubes, electrolytes tubes, sorry. Sometimes there may be a spelling mistakes you have to consider. Okay, don't take it as serious. Sir don't know the spellings and giving the classes. Don't think like that, guys. Okay, those are common. Semiconductors, vacuum tubes, and electrolytes, not applicable to insulators. For all these, it is not at all applicable. Okay, and coming to the curve belongs to Ohm's law. There is one important question on this. The curve is nothing but, if you draw the curve between voltage and current, here voltage, here current. As you increase the voltage, current also increases now, so you will get the curve is like this. So this curve starting from origin and it is a straight line. So the slope is nothing but resistance. The slope, change in y-axis by change in x-axis, now that is v by I. So slope is nothing but resistance. Slope is nothing but resistance. Here the curve, straight line passing through origin. Straight line passing through origin. So this type of curve is called as linear. Very important. Linear. The curve representing the Ohm's law is linear. Okay, so note down the point. The curve representing Ohm's law is linear curve. This is also very important, guys. Okay, so we have completed potential difference and also the Ohm's law. Okay. Yes. In the next session, we will discuss the parameters are in series and parallel. That means if you connect the resistors in series, what will happen? In parallel, what will happen? Okay. So I will give all the important points in that session. All of you, thank you so much for watching. And if you like my classes, please be share to your friends, and also if you want to give any comments, you can also give the comment. Okay, please encourage me with your comments and likes. That makes me to take more classes. Okay, thank you so much, guys.